Hey Certheads, ready to supercharge your Azure skills? In today's video, you're diving deep into Azure VM storage like never before. But hold on, this isn't just a tech talk. We're going to make it fun, simple, and packed with hands-on tips. We are exploring managed disks and caching for VMs, and even mysterious Write Accelerator. Yes, it sounds as fast as it is. Plus, we will talk about database sizing, Azure storage tips, and because we love getting practical, we are introducing a Terraform tfVars file to make your code more reusable than ever. Stick around till the end because we will also hit up a quick question and answers for that certification, managed and unmanaged disks. So what's the deal with managed and unmanaged disks? So when you create a VM, we already know that these disks are stored in storage accounts. You can choose between two types of storage accounts, either a managed or an unmanaged storage account. Now what is unmanaged disks? This is like packing your own luggage, and then you are responsible for making sure it fits in the storage compartment. No fun when you have a huge number of VMs, right? Managed disks. Think of this as having someone else organize your luggage for you. Now what Microsoft does is it handles all the heavy lifting, so you don't have to worry about managing individual VHD files. There is a breaking news. As of January 30, 2024, unmanaged disks are going away. What does that mean? You will not have the option of creating unmanaged disks anywhere in the portal anymore. Why should you care? Well, managed disks offer better reliability for your SAP workloads, especially when you are using availability sets. This makes sure your disks are isolated, giving you more robust failover systems. Now let's talk about performance. Azure Managed Disks come in 5 different performance tiers depending on your workload needs. Important tip, there is a concept of throughput and IOPS discussed here. If you want to understand that, please refer to the video linked above. Now let's talk about performance. Standard HDD, standard hard disk drives, maximum throughput is 500 MB per second and maximum IOPS is 2000 to 3000. This is perfect for backups or non-critical infrequent data. Standard SSD, the throughput is 750 Mbps and IOPS is 6000. The maximum size of this particular disk can go up to 32 TB, ideal for lightly used enterprise apps or a dev test environment. Premium SSD. Now we are getting into production level performance. Think of SAP database or performance sensitive workloads. Throughput is 900 MB per second and IOPS is 20,000. Premium SSD V2. For workloads requiring ultra low latency, throughput is 1200 Mbps. IOPS is 80,000. But one catch, this disk cannot be used as an OS disk. And finally, the Mega Disk Ultra Disks. Throughput is 4000 Mbps and the IOPS is staggering 1,60,000. Now I have a pro tip for you for SAP workloads. Now if you are deploying SAP workloads in your production system right now, there are a few things which you need to keep in mind. Always calculate the total IOPS and throughput for all your attached disks combined. This will help you avoid bottlenecks. And tip number 2, you can mix and match disk types. Use plain SSD for your OS and premium SSD or higher for your SAP database data disks. This will save you cost. And just make sure you test the performance before you implement it. VM and data disk caching. So here's the deal. Whenever you mount a disk on your virtual machine, caching is enabled by default. This is known as host caching. And why is this a big deal? Because caching gives you faster read and write performance than using a normal storage. Here's how it works. When data is written on your disk, it doesn't directly go there. Instead, the data is first written on a cache storage. This cache storage is on the host where the VM is running. So what do you mean by a host? The host is basically the VM rack on which the VM has been created. After that, it's written into the actual disk. This process is much quicker because the cache storage has a faster read and write performance. Let's talk about some pro tips. When you're running something as performance sensitive as SAP workload, this caching feature can make a noticeable difference in speeding up those transactions. While caching speeds things up, make sure your VM and your disk configuration are taken into account. for optimal performance, especially if you are dealing with larger databases. Following are the possible cache types in standard and premium disks. You can go for none, which means the cache storage will completely be skipped and the data will directly be written on the disk. You can go for a read, which means the write operations will not be cached. The only operations which be cached are read. You can also go for read write. This is a default option. A read write is always going through a cache memory. If you have made it so far and if you're finding these deep dives into Azure and Terraform useful, do me a huge favor. Hit that like button. It really helps the channel grow. Don't forget to subscribe and ring that bell icon so you are first in line when new content drops. Got questions or thoughts on today's topics? Leave them in the comment section below and I'll try to get back to you. And of course, share this video with your fellow cloud enthusiasts. Let's build an awesome community here at Certheads. Let's keep conquering the cloud together. Let's head over to our portal and create a VM and disk and check all the caching options. This is the resource group. Pretty good. Now I'll go ahead and create a virtual machine here. Let's select virtual machine. I'll give it a name. All the default options. I don't need a redundancy. Let us select Windows and give it a username and password. So I'll keep all the default options and click on networking. I'll select the network which we have created, but the subnet has to be workload subnet. Click on next. I'll disable the boot diagnostics. We don't require it. Click on next, review and create. So the deployment is in progress right now. We'll wait for it to complete. So the virtual machine has been created. So let's create a new disk. The LUN is basically the logical unit number of the disk. So let it be LUN 0. We'll give it a name, Certhead VM1 or disk 1. The type is Premium SSD. The size is, let's say, 40 GB. As you can see, as you increase the size, the IOPS will also increase. If I increase it to 250 GB, accordingly the IOPS will increase. So now what we need to look here, the caching options. So here you can set the host caching options either to none, which means the VM write will directly happen on the disk. It will not write on the cache. If you set it to read only, the VM will away write on the disk, but it will not read directly from the disk. The reading will happen from the cache drive. And if you set it for read write, then read and write are going to happen on the cache Write Accelerator. If you're working with modern databases and you need to speed up your log file updates, this is the tool for you. So let's break it down. What is a Write Accelerator? Write Accelerator is a disk capability designed specifically for M-series virtual machines with premium disks. Its job? To reduce the I/O latency of writes on the disks. Why use Write Accelerator? Well, if you're working with databases that have frequent log file updates like transaction heavy workloads or databases like SAP HANA, you need those writes to be super fast. This is especially useful when you need super fast updates on transaction logs or redo logs of your database. That's where Write Accelerator comes in. It boosts write speed and keeps your logs running smoothly. Write Accelerator can only be used on volumes that hold transaction logs or redo logs, not data volumes. It's optimized for log writes only. You should keep that in mind. Before you jump in, some key constraints you should watch out for. Disk caching should be set to none or read only. Write Accelerator enabled disks do not support Azure backup, but don't worry, they'll restore as normal disks. And also make sure only smaller IO blocks less than 512 kilobytes are processed through this accelerated path. Also, don't forget there are limits on the number of Azure Premium VHDs that can support Write Accelerator per virtual machine. So keep that in mind when you're planning your infrastructure. General database sizing. How to size your Azure virtual machines to meet your database requirements. Whether you're planning a new deployment or migrating existing workloads, understanding these factors is key to a high-performing database setup. Let's dive right in. Here are the main factors you need to consider when sizing your virtual machines. The number of data files. How many do you have and how are they spread across the disks? The disk count. How many disks will hold these data files? IOPS quota per disk. Check the IOPS limit for each disk you are attaching to your virtual machine. Throughput per disk. How fast can the data be read and written? Are you attaching additional disks for better performance? Overall throughput limit. What's the max storage throughput for the entire virtual machine? So every virtual machine has a throughput limit. You need to keep that in mind. Azure storage latency. Different Azure storage types offer varying latency levels. And also make sure you consider virtual machine SLA. What is the service level agreement for reliability? Now, why is database sizing so important? Remember, the database performance depends heavily on the underlying storage and the disks, which means the choice of disks and their configurations are critical when you're working with a high demand environment like SAP or any other transaction heavy databases. For any new workload on Azure, you go through an sizing estimate. This will give you an expected IOPS and throughput which you need to meet your workload demands. Use this data to plan your virtual machine sizing and storage configurations very carefully. In migration scenarios, you can get performance insights from underlying storage platform in the database itself. Whether the database has monitoring tools or not, it is essential to track the performance metrics and make an informed decision. Bonus tips for sizing. Make sure you calculate the total IOPS and throughput for all disks attached to the VM. Test thoroughly in the staging environment before pushing any configurations into production. You can also look at a report called ABAP SDF HB sizing, which is used to estimate the hardware requirement of HANA database. Now let's talk Terraform. Let's take a scenario. Imagine you are deploying infrastructure both in dev and QA environments. Each environment has a different settings, right? So naturally, you'd have to manually modify your variables each time you input a new run and then run it again. That's ridiculous. But wait, Terraform has an elegant solution for this tedious process. You can create a reusable file for all your variables, which can be modified as per environment and reused. No need to edit your main code every time. Now you might ask, how will Terraform know which value to pick? Well, Terraform is pretty smart. It automatically looks for any file with .tfVars extension. When it sees this file, it knows that where it should go and grab the values from. Let's jump into our code and we will create a tfVar files for the dev environment. Okay, back to our code now. We are going to first create a Terraform tfVars file. So let's click on add and let's say terraform.tfVars. That's good. The file is now created. Let's come back to the variables file. So what we are going to do is we're going to hash out the default values, which means we will not use the variable file to pick up the values. We will be using the tfVar file. So let's hash it out. That's done. Now let's come back to the tfVars file and we will create the values for the variables. Let me do that quickly. Now one thing to note is the map object which we have declared in the variable section here should be exactly like this. Okay, now let us do a format to make the code look better. So Terraform fmt -recursive. Now let's run a Terraform format to make the code cleaner. Now it looks a bit more cleaner and organized. Everything is clean now, which is good. Now let us go back and run a plan for this code. So Terraform. So as we can see, the plan has executed and exactly the resources which we wanted to create are being displayed here, which is a good sign. Now we will deploy the code. So we will write Terraform apply with an auto approve flag. So the code is deploying now, and the apply is complete. So we removed the variables values from the variables file, and everything is right now there in the tfVars. Okay, time for our bonus content. First question: you are tasked with migrating an on-premises SAP deployment to Azure. The current deployment uses DB2 data store containing 5 TB SAP database, which you plan to migrate to SQL Server on an Azure virtual machine. During this migration, you want to optimize the performance of transaction logs, write operation, to ensure the smooth handling of high I/O workloads. However, the solution you choose must not exceed the I/O quota of the virtual machine. What should you do to meet the requirement? The options are: place the transaction logs on temp disk, place the transaction logs on striped volumes of a premium SSD disk, place the transaction logs on ultra disk, enable write cache for the disk hosts. So the right answer to this is you should place the transaction logs on striped volumes of a premium SSD disk. Now why striped volumes? Because what will happen is when you stripe all the volumes, you will get a higher I/O. You will get the combined I/O performance of all the disks. Remember what we discussed in the previous slides. The next question: you are designing an SAP HANA deployment and you estimate that the database will grow to 1.8 TB in 3 years. You need to ensure that the deployment supports 60,000 IOPS while minimizing cost and providing the lowest possible latency. Which type of disk should you choose? The correct answer is Premium SSD. If you use Ultra disk, the cost will be too high. Hence, in order to minimize the cost, you should use Premium SSD. Alright, Certheads, that wraps up today's deep dive in Azure VM storage and database deployment optimizations. I hope you now have a clear understanding of how to choose the right storage for your workloads, whether it's Premium SSD, Ultra disk, or leveraging features like Write Accelerator to maximize your performance. If you found this video helpful, do not forget to smash that like button. Drop a comment below with your thoughts on what storage type would you be using in your deployments or any questions. And of course, hit the subscribe button and stay updated the latest contents from the channel. I'll see you in the next one.